Math 1314, section IC1, Spring 2022, Tyler Junior College. Section 1.2, Linear Equations, Video 1, Basic Linear Equations. Throughout this semester, throughout this course, I will be recording a series of videos for each section that we will cover in this online co-requisite pair college algebra class. Our first homework is over section 1.2 linear equations. I do not know how many videos I will have in each section. I will know when I record the last one. But the first one for this section is basic linear equations. Before we get into solving basic linear equations, I should point out that you may know how to do a lot of what I'm about to show you in this video. If you do, great. If not, well, then you'll learn something. Before we jump into this, I want to go over something that I think all of you know already, and that goes something like this. If two quantities are equal, then you may do any of the following to both sides of the equation and keep the quantities equal. Number one, add any number to both sides of the equation. I am great at spelling. I'm horrible at typing. Number two, subtract any number from both sides of the equation. Number three, multiply both sides of the equation by any, and here's a catch, non-zero number. Now, you can multiply both sides of an equation by 0, but then it instantly turns the equation into 0 equals 0, and all of your variables get annihilated. And then lastly, divide, told you I can't type worth anything, both sides of the equation by any, and you guessed it, non-zero number. In this case, it's because division by 0 is undefined. So what we're going to do in this video is we're just going to illustrate each of these four moves individually. And in the next video, we'll talk about what to do when we have to do multiple moves in a particular equation. For example, let's say you want to solve the equation x minus 15 equals negative 12, meaning we want to find the value or values for x that would make this equation true. Well, keep in mind that equation solving is a goal-oriented task, and that goal, our goal is to get it down to look like this. X equals some number. In other words, isolate the variable. And basic equation solving strategy is to ask yourself, what is preventing the variable from being by itself, and what can we do to overcome that? Excuse me. In this particular instance, the variable is not by itself because it has this 15 being subtracted from it. So we have to do something to overcome that obstacle to get us towards our goal. All right, so how are we going to pull this off? Well, we're going to use one of our basic moves. Now, guess what basic move we're going to do? I'll give you a hint. To get a letter by itself, we have to undo what has been done to it. And what has been done to this x is 15 has been subtracted from it. So what's the opposite of subtracting 15? Adding 15. What we're going to do is we're going to add 15 to both sides of this equation. Because one of our moves is if we have two equal quantities, we have x minus 15 and we have negative 12, then we can add anything we want to both sides and preserve that equality. So we're going to add 15 to both sides. Now, I know what most people are taught to say. The 15s cancel. And in effect, that's what they actually do. But I want to briefly show you what actually happens because it can help you remember whether or not we're doing the correct move. When you say the 15s cancel, what technically happens is this. You are adding a number and its opposite. And by definition, when you add a number to its opposite, you get 0. So negative 15 and positive 15 give us a positive 0. You could also say negative 0 because 0 is the only number that's the same as whether it's positive or negative. But I'm going to go ahead and write positive 0. And on the right side, of course, over here, we can just do the math. Negative 12 plus 15 is equal to positive 3. If you need some help with arithmetic with positive and negative numbers, let me know and I'll hook you up with some material. But the purpose of adding the 15 is to not necessarily cancel the negative 15, but to turn it into a plus 0. Now, why is that advantageous? Because 0 is the best number to add with. What happens when you add 0 to something? The answer is it doesn't change. So when we see something like x plus 0, we can simply just answer that question. X plus 0 is equal to x. The right side is 3, and just like that, we've met our goal. Now, this isn't how some people do the math. Some people do it like this, and they're both technically okay. But the way I showed you right now is what's going on behind the scenes. You take the subtraction problem and do something to it, in this case, add 15, to turn it into a plus 0, because we can do a plus 0 problem on anything, whether it's a letter or a number, even if we don't know what that, what that letter equals, excuse me. But what most people will typically do is something like this. I'm going to add 15 to both sides. I'm going to cancel the minus 15 and the plus 15. And then over here, this adds to give us 3. And I'll admit that there's nothing technically wrong with that, but it kind of clouds the issue of what's really happening with the negative 15, that it's being turned into the easiest number to add with, namely 0. And you can turn any number into 0 by simply adding its opposite to it. So that's technically what happens on the left side. You get a plus 0, which gets absorbed by the x. But it's okay if you think, I'm just going to add 15 to cancel the minus 15. Just keep in mind, if you're ever stuck as to what move should I do, it's motivated by turning a plus or minus number into a plus 0 so that it disappears into whatever you're being added to. All right, so let's take a look at another one, but this time we're going to have to use subtraction to get the job done. And I wonder what problem is going to invoke subtraction. If you were thinking an addition equation is going to invoke subtraction, then you would be correct. Again, remember, our 4 moves are pretty straightforward. We can add, subtract, multiply, or divide any number we want to preserve an equality. It's just that when we multiply or divide, we can't do it with the number 0. So what moves should we do here? Well, keep in mind that this is all goal-oriented. The goal of any equation is to get the letter by itself, to figure out what the letter equals. So any obstacle that's in your way needs to be addressed. For example, we're not at our goal because the plus 19 is in the way. So we need to do something to counteract the plus 19 to make it, well, basically disappear. And what's the opposite of adding 19? Well, of course, the opposite of adding 19 is subtracting 19. So the move that we would pull off is to subtract 19 from both sides of the equation. So minus 19 on the left side, minus 19 on the right side. And what technically happens is the same thing that happened in the previous example. The plus 19 and the minus 19 together make a plus 0. And on the other side, 10 minus 19 is negative 9. But again, a plus 0 is ignorable because anything plus 0 is itself. Whether that thing is a number or a letter is irrelevant. Q plus 0 is Q. So technically what happens is the Q plus 0 collapses down to a Q, and we get Q equals negative 9. Now, if you want to do it the other way, where you start with the equation and then you write something like minus 19 and minus 19, that's okay. Just remember that your moves are motivated by your goal, which is to get the Q by itself. Some people on a problem like this might do a minus 10 on both sides to cancel the 10s, but canceling the 10s doesn't get you closer to your goal of getting the letter by itself. So identify the goal, get the letter by itself, identify the obstacle that's preventing you from that, the 19, and then take measures to overcome that obstacle. All right, let's take a look at a multiplication equation. For example, let's solve the equation 15 times x equals 35. I assume that everybody knows, but it's worth reminding you that when you see a number adjacent to a letter side by side with nothing in between, the implication is that they're being multiplied. So something like 15x literally means 15 times x. So how do we get there? Well, what's our goal? Get the x by itself. What number is preventing that goal from happening? That 15 in front, excuse me, that's supposed to be highlighted. That 15 is what's preventing us from our goal. How is the 15 attached to the x? It's multiplied. How do you unmultiply something? You divide it. So we are going to divide both sides of this equation by 15 because the 15 is preventing us from our goal. It's preventing us from getting the x by itself. And the reason we're dividing, which I'm going to write as a fraction, is because we are undoing the action of multiplication. Now, I know what most people will say here, cancel the 15s, but the same question as before. Do you know what really happens to the 15s? The end result is they both disappear. But do you know what really happens when you divide 15 by 15? Oh, yeah, anytime you divide anything by itself, it's equal to 1. Or more specifically, anytime you divide a non-zero number, any number besides 0, by itself, you get the number 1. So really what the division move does is it doesn't really cancel the 15, but it changes it to a different number. 15 divided by 15 is 1. And that was not supposed to look like that. 15 divided by 15 is 1. We'll get to the 35 over 15 in just a second. But why is having 1 really convenient when you're multiplying? Because 1 times anything is itself. Normally, when you multiply a letter times a number, you can't answer it except under 2 or 3 circumstances, one of which is when you multiply by 0. Anything times 0 is itself. But what happens when you multiply something by 1? It stays the same. So even though I don't know the value of x, I know the answer to 1 times x because I know the answer to 1 times anything. 1 times anything is itself, so 1 times x is just x, which gets us to our goal. So technically, when you're dividing, you are setting up a division problem to change the number in front of a letter to the number 1 because you can complete the multiplication when the number in front of the letter is a 1. But the net result, as most people know, is that the 15s would just cancel. And again, that's technically okay, but in case you forget, oh no, am I supposed to add, subtract, multiply, or divide? Keep in mind that what you're trying to achieve in all of these moves when you're solving an equation is either, if it's an addition or subtraction issue, you're trying to create the number 0 because adding 0 preserves the value of what you add it to. But if it's a multiplying or dividing issue, you're trying to create the number 1 because the number 1 will preserve the value of whatever you multiply it by or divide 1 into. Now let's get back to the fraction for a second. 35 divided by 15. Normally what you would try to do is just divide this out. But if you were to divide 35 by 15, you'll see it's not a whole number. You get 2 and some left over. If you were to do it as a decimal, you would get 2.33333 repeating. Hear me out now, and you may hear me say this again. Here's my rule about decimals. If the problem doesn't start with a decimal, don't end it with a decimal. There were no decimals at the beginning of this problem. I don't want any at the end. In the homework, it will say type an integer or a fraction in lowest terms. When you set up a division problem like this one, and it won't divide evenly, you should reduce it. And to reduce it, all you have to do is divide both sides of the fraction by any number that will divide into both sides evenly. Sometimes it's obvious. For example, in this case, we can divide the top and the bottom by 5. And then see what we get there. Well, 35 divided by 5 is 7. 15 divided by 5 is 3. That fraction is in lowest terms. So our solution would be 7/3. Don't panic by fractions. They're just division problems that you can't finish. You know the rules for them, and as we go through them, I will remind you what they are. But to summarize, to solve an equation where your goal is being obstructed because your letter is multiplied by something, the move is to divide by that something, which technically turns it into the number 1, but effectively cancels it, getting you to your goal. All right, let's take a look at one more to wrap up this video. Solve the equation x over 6 equals -5. Oh no, a fraction. I'm going to run around throwing my hands in the air, screaming, in all sorts of panic because it's a fraction and fractions are hard. In a word, no, they're not. You just think they're hard because some people that taught you fractions might have been scared of them. But the truth is, most of the time, a fraction can be dealt with by looking at it as a division problem. The exception is when you're adding and subtracting, but we can cross that bridge when we get there. So how would we solve the equation x divided by 6 equals -5? And notice I said x divided by 6 and not x over 6. Yes, they're the same thing, but by saying x divided by 6, it can help me focus on my goal and what's preventing me from getting there. My goal, of course, is to get the x by itself. And what is preventing us from being there? What is preventing us from being at our goal at the beginning? And the answer is the over 6, or more importantly, the divided by 6. Now, why focus on that? Well, we're allowed to do the same thing to both sides of the equation, a couple of exceptions involving the number 0, but we want to do something to counteract the action of dividing by 6. So what is the opposite of dividing by 6? Of course, the answer is multiply by 6. So our move is going to be to multiply both sides of this equation by 6. Technically, what happens is this. we are setting up a division problem that we can answer. 6 divided by 6. And of course, 6 divided by 6 is 1. That will leave us 1 times x. Remember, 1 is the perfect number to multiply by because 1 times x is equal to x. So the net result of multiplying both sides by 6 is we can essentially cancel the 6's. And that will leave us with an x on the left side, which is our goal. And on the right side, it boils down to figuring out what -5 times 6 is. Of course, -5 times 6 is -30. Now, if you were thinking it was +30 because the 6 is larger, you're thinking about the rule for adding positives and negatives. The rule for multiplying positives and negatives is easy. Positive times positive is positive. Negative times negative is positive. But 1 positive times 1 negative is always a negative. Goal met. X is equal to -30. In the next video, we're going to look at some examples where we have to do multiple moves to get the equation solved. For example, we're going to look at things like how do you solve something like 3x minus 1 equals 19, or how do you solve something like -2x plus 7 all over 3 equals, oh, heaven help us, we'll say, we'll just put a number like 5 over there. And it's really not that hard as long as you know one thing, the order of operations. We'll see that in the next video.